the truss geometry and choose truss member sizes that would be suitable for carrying highway loads. Okay? Questions? You good on that? Move this down out of the way again. Okay, and they've got a lot of choice in this, which is great too. They're told, again, their objectives, safety, and cost. And then if they want the complete design specifications, they can go to health. And what you're going to see on the screens is there's always going to be somewhere in there where it's keeping track of costs for you. And I think that that is really kind of cool. So they're given what their river gorge looks like. Okay, so they know what's going on with that. And if we go on to the next, this one allows them to, are they working in a, there's also the national contest, there's also local contests that can be set up, and West Point will help with that. We're not fooling with a local contest right now, so we'll get out of here. Now they get into where they get to select things. And it's a trade-off, and everything in engineering is a trade-off that we do. So we start off with, and they'll tell us, we need to make some decisions about our bridge, how we're siting it. We need to decide where the deck elevation is going to go. This one right now is set to be 24 meters above the water level, but I can bring it down. Now, what would happen if I brought it down? Well, let's say I bring it down to 12 meters, okay? What I've done is I've cut down on the distance I have to span, which means that my bridge cost is going to shrink accordingly, right? Don't have to build as long of a bridge. On the other hand, to achieve that, I've got a lot of site work I've got to do. I'm going to have to excavate, okay? And then I'm going to have to build the roadway to get down here. And so what you see here is my site cost, which includes the cost of the bridge deck, the excavation I'm going to have to do, and the supports I'm going to build, but it doesn't include the cost of the bridge itself, the steel trusses. My site cost, when I set that at 12 meters, went up to $91,500, whereas when I had my bridge up here, my site cost was $55,000. Okay? And so the students need to weigh, am I better off investing money in site work for a bridge that's not going to be as expensive, or am I going to minimize the site work and end up with a more expensive bridge because it's got to span a longer distance? Okay? I'll talk to them and we'll pull in other things as well. What if I were to bring this down to 0 meters? Now I've got $120,000 site cost and a very short bridge. Okay, my structural cost isn't going to be real great there. But that might not be a good solution depending upon the application I'm looking at. Okay? Why might that be a problem? Flooding. Flooding, possibly. So, navigable. And it's not navigable. I may have, if this is a body of water that's used for even just recreation purposes, I may have a lot of people a little bit upset if I set my bridge that low. I'm going to have to be talking to my water resources people about, am I going to have flooding problems with the bridge this low as well. So there's a lot more than just the construction engineers and the structural engineers and the geotechnical engineers that would deal with the foundations, the abutments, okay? I'm going to need to be talking to hydrologists, water resource engineers, maybe environmental engineers, and some of those other types of aspects. So a project of this nature involves a whole array of different engineering specialties working together to be able to accomplish it. So I'm going to make a decision here on where I'm going to set my deck. I'll put mine at, let's say, 8 meters, okay, with a $100,000 site cost. And then I need to decide, am I using these standard abutments or am I going with arch abutments, okay? And if I'm going with arch abutments, how high am I making that arch, 4 meters, or am I going to cut it down to 8 meters? And notice that the site cost is affected with all of those decisions. If I go with arch abutments, I can't have a pier, okay? If I do standard abutments, I need to decide no pier spanning one, or am I putting a pier in, which will have 2 spans, and how high am I putting that pier in, the whole way up to the bridge deck, or somewhere down below it, and again, whoa, my site cost went way up there. And then am I going to use no cable anchorages, or am I going to provide a couple of cable anchorages to tie back my bridge into the underlying rock? And again, I have a huge site cost now, and $149,000 is what I've got. I'm going to take the cable anchorages out and the pier out and go with one span. There I am, I'm back down to about $101,000. So lots of decisions to be made here before they ever get around to even designing their bridge. And again, you've got a help screen, okay, that will give you, for more information on selecting a site configuration, click the help button below. And it will give that student that has the interest to learn more, plus more background information on all of these decisions to be made. Questions? You good?
I have one question. How do they come up with a site cost? Is there like an average across the country?
Yeah, and that's what they would be doing. And these costs are representative, but not exact. Yes, they're going to be looking at data for what would be typical for that kind of construction. Yeah. Working there. Whether they're doing it with an average over the country or whether they're doing it for the West Point area, I'm not sure. But they're using representative costs. So if I go on now to my next screen, I get to select now deck material and truck loading. Okay? Deck material can be, I can use medium strength concrete or I can use high strength concrete. Okay? Now, high strength concrete is going to be more expensive, okay? But it's stronger, which means that I should be able to get by with a thinner deck. Okay? So the decision has to be, again, another trade-off. Am I better off with a 0.23 meter thick deck of medium strength concrete, or am I going to go into high strength concrete and make that deck less thick? If the deck is less thick, what's the advantage to that?
Lighter.
Less weight, less load, and a lot of the load on a bridge is going to be instead load. Now, if I'm designing a bridge up there at 24 meters that's real long, okay, maybe high strength concrete makes sense to minimize weight. If I've shortened up my span, maybe it's not worth it to use the high strength concrete. But again, we're going to make decisions about that. And then we're going to look at, and they can actually design for two different kinds of loading. I'm going to leave myself at medium strength concrete. Here you're looking at what they'll call the standard truck loading, 180 kilonewton truck. It's a two-lane bridge, so we put them side by side, one in each lane, trucks passing each other. But you know, there are times when we do permit loading, you know, you see those wide, heavy loads coming through, okay? So that's a 660 kilonewton permit loading, and we're going to run that down